Hi friends, in this video we are going to see the statistical inference used in data science. So before knowing with the statistical inference, why we need this statistical inference? So you want to do a study on political attitudes about the young people. So maybe in India you may have some 3 lakhs undergraduate students. So to do the survey, you cannot go to the individual students and to get the opinion about them. It is not practical to collect the data from all of them. So what we can do is you can select some sample of 300 undergraduate students from any of the 3 universities and you can collect the information from them. And that students information you can use to get an inference about the whole student population in India. So as what you know about statistical inference or inferential statistics is used to draw the inference about the entire population based on some sample from the huge population. So before to know about these words, you need to know what is meant by population. So population is the entire group that you want to draw the conclusion about. So for example, I want to know the political attitude about all the young people. So this is my population. So I cannot directly go and collect the data from all of them. It is not practically possible. So what we are going to do, we are doing some sampling technique. So based on that, we'll collect some samples out of that. So maybe I will select some 300 students from any of the 3 colleges or universities. And I will do the survey on this small group of people. So that is called a sample. A sample is a specific group of people from where you can collect the data. The size of the sample will be always less than the size of the total population. So from this sample, you will try to infer some details, and that details you will tell the information about the population. So based on the inference achieved from the sample, we can generalize that information to the population. So since you may know this also, so you want to know about the survey about some information, that is survey about a particular product. So we cannot go and ask every individual about the product. So what they will do, they will collect the survey from the persons who are visiting to the mall. So from the sample of people, they will get the inference, and based on that, they will give the generalization about the population. So that is called as statistical inference or the inferential statistics. And so if you want to do so, one of the thing you are going to infer the information from the population is mean. So here what you need to do is we have 2 types of means. So one is called as sample mean and another one is called as population mean. So what is mean by sample mean? So sample mean is a small set of people, around 300 students. You are taking the mean of their height or mean of their weight. What about that? And then population means it is a mean of the all persons available in the population in the universal. But it will not be possible because you cannot go each and every one and calculate the weight of everyone. So we can take, I want to take the weight, calculate the mean weight of the persons between the age range of 30 to 40. So I cannot go and check every individual who is having an age of 30 to 40. I cannot go and collect the weight of them. Instead of that, I will select some group of people who have a weight of 30 to 40. So from that, I will do the sample mean, that I will try to use it to estimate my population mean. Okay. So from the sample mean, you can able to infer the population mean. So mean means you know that average of all the data points, and here the small n represents the number of items you use it in the sample data. The capital N represents the number of items that is available in our population. And then you have this x dash will be represented as a sample mean and mu will be represented as a population mean. So generally if your sample is random and your sample size is larger, then generally your sample mean will be a good estimate to calculate your population mean. Actually, we don't know the population mean. So, we are calculating the sample mean. From that, we are going to estimate the population mean. So, generally what happens if you calculate the sample mean will not be same as the population mean. But sometimes if you do it again and again, you repeat your experiment multiple times, you can get the sample mean as same as the population mean. Okay. So generally the sample mean is the estimate of the population mean. It not be exact as population mean, but it is an estimate of population mean. If you do your experiments repeatedly by taking different samples and doing it multiple times, there may be a chance that your sample mean will be equal to your population mean. And now you are calculating the sample mean. So we don't know what is our population mean, but we are going to estimate our population mean through this sample mean. So to estimate that, we need to calculate the confidential interval. So we are based on this calculated sample mean, we are going to tell our population mean lies between this confidential interval. Okay. So confidential interval. So by estimating this sample mean, we are going to give a statistical inference that our population mean will be in the range of this confidential interval. So now we have calculated the sample mean. By using the sample mean, how we are going to estimate the confidential interval so that we can tell our population mean will be lies inside this confidential interval. So the parameter or the unknown value to you is the population mean. So this will be generally called as parameter. The parameter is an unknown thing. Here in our case it is a population mean. So confidential interval will tell the probability that the population mean or the parameter will fall between the pair of values around the mean. So by using the confidential interval, we can able to identify that your population mean will be lies within the interval of your confidential interval by using the calculated mean value of your sample. And they are mainly constructed with different confidential levels, that is of the generally used confidential levels are 95% and 99%. And this is the formula for calculating the confidential interval. So from the 300 samples, you know what is the sample mean and then what is the sample standard deviation and how many number of samples you have used, that is 300. And this is the unknown value which is known as Z score. This Z score will be calculated based on our confidential level. If our confidential level is 95%, the Z score will be taken as 1.96. If our confidential level is 99%, then we have to take the Z score value is 2.57. So by using that, you can calculate the confidential interval. So it is plus or minus. So you have a lower range and you have a upper range. And your mean will be lies between, and also we are estimating our population mean also lies between this confidential interval. And now I have given one sample question here, calculating the confidential interval of the mean cholesterol value for the female population. I don't know how many persons are available in a female population. So I want to estimate the mean of the female population with the confidential level of 95%. And to do that, I have taken a sample of 97 females and I have calculated the mean cholesterol for them. It is around 261.75 and with a standard deviation of 64.9. So according to my question, the given values X bar, that is 261.75, and I have given the standard deviation, that is 64.9, and then I have given with the number of samples, that is 97, And here it is asked to calculate the confidential interval for the confidential level 95%. So if it is 95%, the Z score will be 1.96. So Z value is 1.96. So now the confidential interval will be calculated as X bar is 261.75 plus or minus, and our Z value is 1.96 into the standard deviation value is 64.9 divided by root 97. Okay, so if I do this, the plus calculation and minus calculation, so I will get a lower interval of 248.83 and the upper interval of 274.67. So if I draw my diagram, my mean value lies in, the sample mean will be available as 261.75 and my confidential interval will be, here it is 248.83 and here it is 274.67. So we expect, or we are estimating, through the sample mean, our population mean will be lies in between this confidential interval. So if I do with what you mean by this confidential level 95%. Okay, it is not like that 95% of probability you are getting the answer. Okay, it is not the probability. What it means, suppose again I am taking 97 samples from the population and I am doing the calculation and I am repeating this job multiple times. Okay, I am taking different samples of this 97 people and again I am calculating the sample mean and the confidential interval. As a result, 95% of time, okay, 95% of time, my population will be lies between the calculated confidence interval. So that is the thing, it represents 95%. So I can tell 95% confidentially, I can tell that if I repeat the process or the experiment multiple times, almost 95% of the time, my population mean will be lies between this calculated confidential interval. That only this will 95% will tell. If I give 99%, I can ensure that 99% of time my population mean will be available within the given confidential interval. So that only this confidential level will represent. So now we want to experiment this thing as a maths, the statistics, whatever we studied, now how it is going to apply to a data set so that a data scientist can use these statistical inferences to do the data analysis. So I am having one sample data set. I have the sample data set called as Toyota, which contain the car information, the age of the car, the cost of the car, and its number of doors, colors. So several data are available here. So I am going to consider only the price column here. So this, you know, if I want to do with my Python programming to handle my data set, I need to include the pandas. I need to work with statistics. So I am using the stats namespace or the library and then NumPy. And to calculate the square root, I need math. And finally, to do a plotting, I am using the matplotlib. So since you know how to read a CSV file, so you can use with pd.read_CSV. So this will read the CSV file. And the shape represents how many number of items available. So here I can take this as 1436 is my population. Okay, my population. So I'm not going to use this population. Instead of that, from this population I will take some sample and I will calculate the sample mean, and by using that I am going to estimate, or I am going to infer what is my population mean. Okay, so first I am taking my population size. So this is my population size because the first one in a tuple represents the population size. And from the population, I need to randomly choose some samples. Okay. So that to choose random, okay, you are having a random function. But the random function, when you use every time, it will get different random values. So instead of avoiding that, we are putting the seed value. So every time the random value will be come out as a constant value. So you can change this, or you can remove this, and also you can test how your mean value, how the samples every time different samples are taken from your population. So now I have made that seed is 6. You can give 12, whatever it is, okay? And that will give you the random value to be every time constantly. It will take the values from your population. And first, what I have to do is I need to calculate the sample mean. In order to do the sample mean calculation, first I need to pick up the sample from the population, that is out of 1436, I need to take 500 values. So to take 500 samples from the data set only for the price column, I am going to do the analysis only for the price column. So I am going to take the 500 samples out of the 1436. So from the NumPy array, you have a random choice. In that, I am going to apply the column only for the price column. And from that column, I am going to take only 500 samples randomly. Okay. Out of 1436, I am going to randomly select 500 samples. So now the sample is ready. Okay. So after doing that, you need to calculate the sample mean. So you already know that the mean function is available in your data frame. So by using that, just call the data frame dot mean. It will give the mean value of the 500 samples. So if I run it, I am getting the sample mean of 500 samples. That value is 10819. So my population mean also to be nearest to this sample mean. So from this sample mean, I can able to estimate, or I can able to infer that most probably my population mean also lies near to 10,800 or 10,000 range. It will available. So that I can decide only by calculating my confidential interval. And now what I am going to do is I am taking another set of 1000 samples out of the 1436. So same thing, you are using a random choice in the price column. Instead of using 500 samples, now we have selected 1000 samples. And for the 1000 samples also, we are going to calculate the mean. So that is also around 10,680. So from these two, the sample you have randomly selected 500 and calculated the mean. The sample you have selected randomly 1000 and you calculated the mean. So almost your mean will be around 10,000 and near to that. Okay, so this sample mean will conforming to you, your population mean will be around 10,000. So that you have get the statistical inference from your sample mean. And now you are going to calculate the population mean. Since now we know the number of items available in our population, that is 1436, and for that you are calculating the population mean. So now you just observe your sample mean is almost nearer to your population mean. Your sample mean, whatever you take, is almost nearer to your population mean. Okay, so we are confirming that by calculating the sample mean, I can give an inference about the population mean. And now the next thing is, once you calculated your sample mean, you have to estimate your confidential interval so that you can give me an information that your population mean will be lies within the range of this confidential interval based on your sample mean calculated. So now what we are going to do, we are going to calculate the confidential interval with the sample mean of 500 with the confidence level of 95%. Okay, so since you know with the formula for the confidential interval, the formula for confidential interval, you need the mean, sample mean for the 500 samples, and then you need the Z score. Here it is 95% confidence level, and then you need to calculate the standard deviation for that 500 samples, and the number of samples you are going to use is 500. So that everything is ready. So you need to use with your Python function to calculate all those values. Already for the 500 samples, we calculated the mean, and then for the same set of sample, I am calculating the standard deviation. Next, you need to calculate the confidential interval. To calculate the confidential interval, the confidential level is given, that is 0.95, that is 95%. You need to calculate the equivalent z-score for it. Since you know the value is 1.96, but through program we need to calculate it. So we are calculating the alpha value based on the confidential level, and that will be passed to the statistics function called as norm.ppf. So it will calculate the Z critical value, that is the Z score, but it will have the value as 1.95999. So it need to be rounded to 2 digit. So we have given a round off function and that rounded to 2 digits. So we will calculate, get the value as 1.96 for the Z score to the confidential level 95%. And now we are going to calculate the lower level and the upper level. To do that, we need to subtract and add the error function. That is, the error function is nothing but the critical value or the Z score into standard deviation divided by square root of our sample size. So since you know the formula, this part, okay, this part is calculated, and this part I am going to calculate as an error. That is a standard error, that is Z score into standard deviation divided by root of the number of samples. So that is calculated, and the lower sample it is get subtracted, in the upper sample it get added. So we got a confidential interval, and since you know from the sample mean we calculated this confidential interval, and we are going to check whether our population mean lies between this confidential interval. So we run it and check. Yes, our sample mean is 10819. So based on this sample mean, we have calculated the Z interval. Okay, so so here it is. I will run the program. So we have this. The sample mean of 500 is 10819, and again it went down, it is for 99%. So now we are here. Okay, so we want to calculate for 95%, and it is the sample mean is 1819, and the Z score calculated from the confidential level is 1.96, and based on the sample mean we calculated the confidential interval. That is, in the left side it will be up to 10,500, and in the right side it will be 11,136. And you know what is your population mean from the given data of 1,436? It is 10,730. So now we can ensure that the confidential interval whatever you have calculated through the sample mean, it ensure our population mean will be lies between the confidential interval. So you have observed that particular information from this. And now what we are going to do is, for the same sample mean, the confidential level we are going to change to 99%, and we are going to observe what will happen. Okay. And here also the same thing, we calculated the sample mean, we calculated the standard deviation for the sample. Then for 99% confidential level, we calculated what is the Z score. Okay, the Z score will be around 2.56. And now we calculated the lower level and the upper limit for the confidential interval. And by checking here, now the sample mean is same, but only the confidential level got changed. It is 99%. So our confidential interval is changed to 10,400 to 11,236. Again, we are ensuring our population mean will be lies between your confidential interval. But what you observe from here, when you do with 95% of the confidential level, our confidence interval will be 10,500 to 11,100. And when you increase the confidential level, okay, when you increase the confidential level, what happened to your confidential interval? Okay, the confidential interval get expanded. That is 1500, now it is 1400, and there it is 11,100, and here it will be 11,200. So I think you can observe here. So now I change to 75%. Now I change to 75% and run the program. I will change to 75% and run the program. You see here, it becomes 75%. So 95% means it is 10,500 and it is 11,100. And now if I give it 75%, it becomes 10,600 and it becomes 11,000. So by varying your confidential level, your confidential interval get varied. Okay, so that you are observing from it. And now what we are going to do is we are going to calculate the confidential interval for a sample mean of 500, sample of 500 elements, and with the confidential interval or the confidential level, okay, this confidential level of 95%, we are going to repeat the process. Okay, so we are going to calculate, we are randomly 25 times, we are going to randomly select the samples from the population. Okay, we are going to repeat our experiment 25 times, so that from the population randomly we are going to select 500 samples every time, and we are going to calculate the confidential interval for every 25 times, and we are going to ensure 95% of the time our population mean will be lies inside our confidential interval. Okay, so how we are going to do? So from the population, again I need to calculate, or I need to take only 500 samples, and I need to repeat this process for 25 times. So every 25 times I will get a sample mean and I will get the confidential interval. So to store that information, I am going to have an array to store the sample mean and to store the intervals for every 25 times. And I am going to do this for confidential level of 95%. So I have calculated the Z score for the 95%, that you know with 1.96. And we are calculating the population mean, because we are going to ensure, even though I am doing the experiment 25 times, 95% of the time my population mean will be lies inside the confidential interval. That only we are going to prove it. So we need to do this for 25 times. So we are putting the for loop for repeating for 25 times. And every iteration, we are randomly picking 500 sample from the population of 1436. So we got a sample and we calculated the sample mean. That is for the first iteration, and that you are storing in the array, because 25 times we are going to calculate the sample mean. So every time you calculate, that will be stored or appended in your sample means array. And we are going to calculate the standard deviation for the first set of samples, and based on that you calculate the margin error using the Z critical value and the standard deviation and the number of samples, and you calculate the confidential interval. And this is for the first sample. For the first sample mean, you calculated the confidential interval. So that also you are going to append in an interval array. The same process again you repeat. Take another set of 500 samples from your population, calculate the mean, calculate the standard deviation, calculate the confidential interval. Like that we are repeating our experiment 25 times. So we are getting 25 different sample means and 25 different confidential intervals. So now I am going to print it. Okay, so I am going to print it. Yes, so these are the 25 different sample means I got. Okay, so
I put my population mean because population mean will be calculated only once. So this is my population means. If you see, almost every sample mean will be near to my population mean. So some values only I am getting varying, but almost everything will be nearest to my population mean. So from the inference of my sample mean, I can give an estimate of my population mean. So same thing for every 25 intervals or 25 iterations, we calculated the interval also. This is my first interval, second interval. So every interval confirming me that my population mean will be available within that particular interval. So this I am going to represent in terms of a graph. Okay, in terms of a graph. So for that, you take this graph. So what I am going to do is, in the x-axis, I am going to tell how many iterations I have executed. So 25 iterations I have executed. So I am going with range of 0.1 to 25. Then only it will display it. Okay, if I give 1 to 25 means the graph is not coming properly. So it is given with 0.1 to 25. Every time it will increment by 1. So that will come in my x-axis. The y-axis, I need to display all my sample means calculated for 25 iterations. So when I run it, yes, so I got for every iteration, what is my sample mean that get displayed here. And based on the sample mean only, I have calculated my confidential interval. Okay. So next, you need to display my confidential interval. So from the interval array, for every iteration, take the confidential interval top level and the bottom level. And that you are going to print it here. Okay, you see here for the first sample mean 10794. Yes, it is around 10794 and its confidential interval is 10,495 and 11,093. 10,495, 11,000. So for every iteration, the corresponding sample mean and the confidential interval will be plotted in the graph. Okay, that you can use it here. X-axis is your iteration, y-axis is your sample mean, and then that line plot you give your confidential interval, the lower level and the upper level, top and bottom. And now you need to display what is your population mean in that. So now I take with horizontal line, I need to draw a horizontal line so that I can ensure every time my population mean will be lies between the confidential interval. So the minimum is 0, maximum is 25 and the y plotting every time my population mean is same only. So y equal to pm and the line width and the color. So run it. Yes. So now you can ensure almost, okay, almost every 25 times my population mean will be lies within the interval. This is my lower interval, upper interval of the confidential interval. Every time my population interval will be lies inside the confidential interval only. So here and all it's almost near to it. So that's why it is given 95% of the time. If you repeat your experiment 95% of your time, you can ensure your population mean will be lies within the confidential interval. So you can give a title. So that will help you to understand about the confidential interval for 25 trials. So this is the way how you are doing your statistical inference. We are calculating the sample mean. From that, we are estimating the population mean to ensure that is your population mean and the sample mean. By calculating your sample mean, you can tell that the population mean also near to the sample mean. And you can able to, or you need to define in which interval the population mean will be lies based on your estimated sample mean. So to do that, you are calculating the confidential interval. So from the calculated sample mean, you are defining a boundary with the confidential interval so that you are ensuring that or you are inferring that your population mean will lies between the calculated confidential interval with the various confidential levels. That is 95%, 99%. So it will tell you almost 99%. If you repeat the experiment, you can ensure your population mean will always lies within the confidential interval. So I think you have got an idea of how to calculate your sample mean for various sample sizes and how you can ensure your population mean will lies within the confidential interval by calculating the confidential interval using the formulas. Thank you.